Hello, everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the Program Manager at the Microsoft Reactor Toronto. I will be sharing session resources with you in the chat, but before we begin, I'd like to quickly review two items, our Code of Conduct and Event Guidelines. First, please take a moment to review our Code of Conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. This session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I will be sharing the link in the chat for our channel. And if you have not been on a live stream to YouTube before, please note that you must create an account on YouTube in order to have access and interact in the chat. You can set that up now, and if you're unable to use the chat but have questions, feel free to reach out to us through social media or on our website. Which brings us to today's session. Today is the last session of the Season of AI for Developers series. I'm going to bring in our speaker here. Hi, Luis. Hi, Pablito.
Hi, Alexia. Thank you for the great introduction and for the support during this series. Hi, Pablito.
Yeah, this was such a pleasure. I mean, we're not done yet, but it was so great having you for 5 weeks now. So yeah, thank you.
Thank you.
Well,
Hi, Pablito.
Thank you very much for the introduction, Alexia. Thank you, Luis. Well, hello, everyone, and good day to you, and good afternoon, depending on where you are joining us from. I'm here with a bit of bittersweet feeling. Is the our sensation as we are now talking about the last session of this series. It's been interesting, but we are happy to have come this far. Looking ahead, I am sure we will be discussing this topic in future events and sessions, and let us know how you found this series. Did you learn something new? And if you like to see more of this kind of session, please share your through with us.
Yeah, you said it. Your opinion is important. Your feedback is important to us. So please share it so we know how we are doing and if you are interested in learning more about this series. Okay, so welcome to our final session, Build Your Own Copilot Solution with Semantic Kernel. So we will take from the topic that we learned last week. Specifically, we will start with plugins, and we will discuss how you can integrate your code with Semantic Kernel and the AI. We will talk a bit about function calling and memories, and if there is, and of course, we will also show a Copilot solution. If there is time, we will also show a couple of demos that you might find interesting. So we have a lot of things to discuss, so I think we can get started. So, Pablito, can you talk us a bit about plugins?
Yes. Well, this topic of plugins, which we have already been reviewing and discussing on previous occasions, last episode, is crucial. We talk about prompts, and currently, when you want to build an advanced or dynamic prompt that you can parameterize it, you will eventually find yourself creating a plugin. The same happens with functions. When you want to integrate artificial intelligence with your code, sooner or later, you will need to work with a specific function. Last week, we shared an example where a function was used with a decorator called a kernel function. This decorator allows you to later create a plugin from that function. A plugin in this context is essentially an extension of your code that allow AI to use your function to answer user question or assistant in a specific task. Um, Plugins act as a bridge between your code and, for example, a database or a REST API call, passing the necessary arguments. The AI or the artificial intelligence intervenes in this process by detecting the entities and arguments that a function needs. Moreover, it can identify within a collection of function market as kernel function, which one is most suitable to solve a problem or assist in a specific task. Um, well, these functions or methods belong to different classes and are designing for a particular domain, solution, or system that you are developing. For example, you might have a function to send an email, another to work with Microsoft Graph API to check user schedule, for example, or code to access database and APIs. All of these integrate with your code are an artificial intelligence to create a smarter and more efficient solutions. Um, Next slide, Luis. Perfect. Here, well, at a high level, applying is a group of functions that can be exposed to AI apps and services. The functions within plugins can then be orchestrated by an AI application to accomplish user requests. Within Semantic Kernel, you can invoke these functions automatically with function calling. For this function to be effective, it's necessary to describe in detail what each one does, allowing the AI to understand and use them correctly. In this example of the writer plugin, show in the image, the functions have description that explain what they do. For instance, the short poem function turns a scenario into a short and entertaining poem. And the story gen function generates a list of the synopsis for a novel or story. Sorry. In the image, when a user asks for a short poem about living in Dublin and then wants a story based on that poem, the AI will automatically call the short poem and story gen function to fulfill the user request, thanks to the provided descriptions. This is the magic of the orchestrator, which we will go over in more detail later with the demos. Next, Luis. So, in summary, here it is. The decorators are essential for indicating which function should be accessible to the language model, the LLMs. Description of these functions are optional, but definitively help the LLMs identify which function is most appropriate to use in each case. This is something we have already seen and worked on with several examples last week. So this is just a brief review, okay? It is important to note that it's not necessary to decorate all functions. Only those you want to integrate with artificial intelligence or the assistant. By exposing this function, you can see how for example, we might have a method to get the status of a specific line using an identifier. This allows when a user says something like, what is the status of all the likes? A combination of function to be performant. First, retrieve all the likes and then iterate over each one to get its specific status, executing the getState function multiple times with the corresponding identifiers. However, we also have full control over this process. We can instruct the system to invoke a specific function if we wish, ensuring that is execute according to our needs. Next slide. Well, here we have the kernel acts as our orchestrator, relying on a component called the planner, which Luis will later demonstrate in a demo. Essentially, this line of code represents the planner, which is responsible for allowing the AI to determine which function should be executed. This is achieved through the tool called behavior dot auto invoke kernel function behavior. In summary, to use a plugin is need to be registered whether you are using your own or an integrated one. As we mentioned and demonstrated in a demo last week, Semantic Kernel includes several built-in plugins, such as the time plugin, summary plugin, conversation plugin, among others. Each plugin is assigned a specific identifier. This is the plugin we add that allows the language model to determine which function should be executed when a question is asked. Finally, we receive an integrated text response that reflects the execution of the selected function. Luis, next slide. Well, here are some of the plugins that I already included in the semantic kernel library. For example, well, we have the math plugin, specifically designed to perform calculation and arithmetic operation, the time plugin, text plugin, and HTTP plugin, which allows invoke APIs. Additionally, it already includes a Microsoft Graph plugin, which is ideal if you don't want to implement your own solution. This plugin makes it easy to work with the APIs for OneDrive, Outlook, and other services. To use this plugin, you need to add the semantic kernel.plugin.microsoft or semantic kernel.plugin.core library. As we mentioned earlier, this step is essential. You must register the plugin you want to use, even if it is already integrated. For example, to use the time plugin, you need to invoke it directly. It's important to consult the documentation to know the available function, and if you are making a query through a prompt, ensure that is relevant to time, as showed last week in the demo, in the example. Next slide. Well, you can also use text files to organize your prompts. which is useful if you have a collection of plugins or prompts that you want to reuse in different applications. For this, the prompts must be in a specific folder, such as a folder called prompt plugin, which will we discuss later as a concept similar to a class. Next slide. Oh. Each prompt must have two specific files, config.json and semantic kernel prompt.txt. The txt file contains all the content of the prompt, instruction, output format, additional data, etc. If you want to add dynamisms, use the concept of a prompt template, where you place the variables in config JSON file. Where in the config JSON we configure three elements: execution settings, such as the maximum number of tokens and the temperature, a brief description of the prompt so that the LLM's model can benefit from the metadata, and the input variables of the prompt template, such as input and style. Next slide. Well, to link everything together, you must include this file in the output directory when working with Visual Studio. Then prepare the kernel arguments, place the key and the value in the dictionary, and use invoke async to execute a specific plugin, passing the different prompts and selecting the one you need. Well, Luis, can you show us a demo about that?
Yes, of course. Yes, thank you very much for the explanation, for all the details, Pablito. Good. So it's time for a demo. Let's see. Okay, good. So, well, this demo, I will explain it in detail later, but because it covers some part of monitoring and also setting up a budget and so. The idea is that for the moment, we have a plugin. This plugin uses or sends a REST API request to Open Weather Map. Maybe you have heard about this service. This one provides weather information about a city. And of course, there are other methods, but in this case, I'm just covering a very simple method. What's the current weather of a city? And well, I also include in the description that the response is in JSON format, because as you can see, we return a string. So yeah, I might have 10, 20 methods, functions in this class, but only those decorated with the kernel function attribute will be available for the AI to use it, either automatically if we set the auto-invoke kernel function, or manually, as Pablito mentioned, with the invoke async function. Yeah, but with this, we make it available for integrating with the AI. Then what's next? We have an argument for this function, city, and we also describe it. So yeah, LLMs are benefit or get benefit if we include this kind of metadata for our functions and also our arguments. So let's see. Okay, and the code, well, it's up to you. Okay, I just send get async request to the backend. I mean the endpoint from Open Weather Map. I use it requires a key. It is a free service, by the way, or it has a free tier. And then you get some response and some error in case that the data is not available at the moment. So I could, invoke this method manually. However, if we set this setting, right, tool call behavior auto-invoke kernel functions, we will be able to provide a prompt that the AI or the LLM will determine, okay, I need to use this function that is provided. This, let's say, this information is passed as context, right, to every prompt. And in this case, we have this question: where is it warmer? Is it in Sunchales, where Pablito is joining us from today, or in Slim, where I'm living? Okay, as I said, I might have 10, 20, and Pablito mentioned when there was example about the short poem. You might have a lot of functions, but the AI will determine which one is required to use and with which arguments. In this case, what is going to happen is that the LLM will determine that the function must be invoked twice. One for this city and another one for the second one. And not only that, because we as users ask something. So besides invoking those functions, the two functions, it will also compare the answers or the responses in order to provide an answer to the user's query. Okay, so let's run it, right? Well, and the rest is just the code that we explain in the slides. So invoke prompt async. As you can see, it is in prompt, not directly the function, right? And okay, let's see. So the first part, don't mind it. Oh, sorry, I got the window here. Okay, don't worry about that one. Let's. This is the second example. This is the code for the user query. It is taking some time, but as you can see, this is the question, and this is the AI's response. It is warmer in Slim because, well, it's we have this temperature in Kelvin. Well, actually, the service returns the temperature in Kelvin. We might have asked to convert it to Celsius degrees, but anyways. And in Sunchales is 283, so about 10 degrees. Is it cold, Pablito?
Yes. Now it's 55 degrees Fahrenheit, and
Okay,
it's cloudy.
okay.
Yeah,
Okay,
it's not
yes.
a good day.
I see. Yes. So, and definitely here, even though it is cloudy, yeah, it is still a bit hot. So like 22 something degrees. Okay. So as you can see, this worked. I mean, we use some code that maybe we already have in our application, and with just very simple decorators, it was easy to integrate it with AI capabilities. So we could, let's say, improve or provide more functions, more capabilities, as I said, to our application. So you can see it is very easy. All you need to do is add the attributes, the decorators, and you will be ready to go. The AI will be able to know about your functions. Okay. We will discuss more examples, or I will go back to this in a minute. And something that is connected to these plugins when it is invoked is planners. Well, because you might have multiple plugins, but you need a way for your AI agent to use them together to solve a user's need or query. And this is where planning comes in. At the beginning, Semantic Kernel had some concept of planners that use prompts to request the AI to choose which functions to invoke. But now, since OpenAI introduced a native way for the model to invoke or call a function known as function calling, other AI models such as Mistral or Gemini have adopted this strategy as a core capability. So it is a cross-model supported feature. Semantic Kernel has evolved to use function calling as the primary way to plan and execute tasks. So this diagram sums up everything that happens behind the scenes. When you make a request to a model with function calling enabled, Semantic Kernel performs the following steps. First of all, the user makes some request. Now, first of all, functions are serialized. All your available functions and the input parameters of each in the kernel are serialized using a JSON schema. Only those which are decorated with kernel function attribute. Then, actually, I think I have an example of that JSON. Just a second. Yeah, this is the JSON that is generated for each function that is marked as kernel function. So you can see the name of some function, its description, the attributes, and so on, right? Maybe we have another one, but this one does not have any description or any arguments. So, okay, that's fine. The description is not required, but it helps, actually, yes. Previously, let's say without semantic kernel or LangChain, you have to manually create this JSON. But now semantic kernel does it for you. And all you need to do is to add the decorators. Okay, so back to this. So once this JSON is ready, the messages, both the request, the prompt, and the functions, JSON's serialized functions, they are sent to the model as part of the input. Third, the model processes the input and generates a response. This response could be either a chat message or a function call because maybe it needs a second one. In the previous example, when I ask about weather information of two cities, it would return a function call because it needs it will return that there is one function, but there is another one. There is a second one with different arguments. So the fourth step can be two things because the response is handled. If the response is a chat message, it is returned to the developer to print the response to the screen, for example, or store it in a database, whatever. If the response is a function call, semantic kernel extracts the function call, the function name, and its parameters. And in the fifth step, this extracted function name and parameters are used to invoke the function in the kernel. The result of the function is sent back to the model as part of the chat history. And then steps 2 to 6 are repeated until the model sends a termination signal. That is a chat response, right? So as you can see, it's some kind of sequential chaining, right? In the end, the user will get some response, but at least one function was invoked, right? I mean, if we set this behavior, right? Oops, sorry. Yes. And if a function was invoked, right? At least one, but in the end, the person will get a response. So this is what happens behind the scenes, right? And this is some kind of JSON that is generated in the last step. This is the response, let's say, after invoking this function, lights change state. And with this answer, the AI assistant will reply or will build an answer to the user's query. Please turn on light number 1. So this is executed and the lamp is now on. Okay, I already explained this. And yeah, this is, as I said, how is it like determined that some function should be invoked, right? This is the function to invoke and the arguments that will be passed. Okay, so rather than a demo, because it is exactly the same as I mentioned, right? This is the benefit of setting up the auto-invoke kernel functions, because that way you can use directly the invoke prompt async. But you always have the control. If you don't want this, I mean, if you want to manually execute the functions, well, yes, you can. You will use invoke async, and then you need to pass the plugin name or reference and the function name or reference. Okay, so in the end, you have the control of what you want to do. And yeah, all you need to do, of course, is also to add it to the plugins collection. Okay, I think we have talked enough about plugins. Let's move to an interesting topic, which is about memories. And you will see how easy it is to build some kind of RAG solution thanks to memories and vector databases. Okay, so what are memories? The idea of memories is that they will provide more context for our prompts. They are what make computations relevant to the task that we want to perform. And it involves embeddings. And if you remember, we have already discussed embeddings, RAG pattern in session number 2. And it helps us to actually to build applications around semantic search memory. What is semantic search? Basically, is a comparison of the meaning of some documents with the meaning of a user's query. And then, of course, we can discuss that, okay, what is a memory? The idea is that you retain you retain some knowledge, some information, right? And this is provided as context for an LLM. If you remember, the LLM has a cut-off date, so it is not possible to answer questions from recent data or private data, right? Our data. But if we provide the right context, then they will be able to help, to assist with this task. But of course, the key is to know which document needs to be passed or sent as context, because we might have 100, 1,000 documents. Which one is the right one or the most probable, the most helpful one, right? So we can do that through embeddings, right? And this in the end help us to build a semantic memory based solution. So if you remember, embeddings are vector representations of words in multidimensional space. We might have some word newspaper and we convert it to vector, to a float vector representation. But it is not only about a word. It could be the content, for example, of a magazine or each page of a magazine, or maybe we have an image, right, as I represent here. Yes, it doesn't matter if you have different types of unstructured data. In the end, we have some models that extract the audio and convert it into text, and we also have computer vision models which can describe what is happening in the image or what entities are there. So in the end, we can get text. So this text is passed to an embedding model in order to generate the vector embeddings. I will go back to this in a minute. Yes. These vector embeddings, yes, they look like random numbers, right? But each of them symbolizes the relatedness of category, some category. And those vectors, those terms, which are similar will be closer, right? And this is the representation, right? The similarity. Similar words, similar data aligned to similar vectors. Later, when the user asks something, this query will be vectorized, and the numbers will be compared to all the vectors that we have in order to find the closer one, the most similar ones. Yes. And that's helpful, or that's where the vector database comes in, because generating vector embeddings is costly and takes time. Well, not costly, but there is a cost associated, right? So if these vector embeddings of your data that is already there, your documents that most probably will not change, they can be stored in a database. And well, there are specific or specialized vector databases, such as Chroma, Pinecone, Azure AI Search, Cosmos DB for NoSQL, Cosmos DB for MongoDB, and others. And there might be others, even Redis, right? But these are available connectors in Semantic Kernel, so we can use them. All we need to do is to add some Nugget packages. Well, of course, Semantic Kernel, we already know that one. But we have here the Azure AI Search connector, OpenAI connector, and this is the most important one, plugins memory. Okay, so Semantic Kernel, you already know the purpose of it. This AI Search will allow us to use an Azure AI Search resource where we will store the embeddings, and it will also be helpful to for search or answering a user's query. This one, OpenAI, is to use an OpenAI model, such as embeddings, right? Version 2 or version 3, both are supported, and plugins memory enables all the capabilities that we have mentioned. Okay, please notice that with very few lines of code, we will be able to build a search index and actually embed the information and store it there. Okay, I omitted some code about the kernel. Let's say you already know how to set up a kernel, right? But first of all, we prepare a memory. In this memory, we are connecting or registering two elements in this memory builder, right? The embedding model that will be used to generate these vectors. So of course, we have an embedding deployment name, an Azure OpenAI endpoint, and Azure OpenAI key. There are other connectors available, right? So you can use Hugging Face models if you want, and probably they will not need any key. Okay, yes, you can. Just don't forget that these models might not be compatible, I mean, between each other. So if you generate, even in versions, right? If you generate embeddings using version 3, large, they will not be compatible or supported by other embedding version 2, right? With OpenAI. So just don't forget that. So here we set our embedding generation model. Then we also include which memory store, which vector database we are going to use. And in this case, we set up an Azure AI Search memory store. You can use Chroma, Pinecone, others, Cosmos, MongoDB. All we need is the endpoint and the key. Once we prepare our memory, we will be able to generate the embedding of some information. Let's say that I have 2 text files. Of course, if you have a PDF, you need to use document intelligence or some library that allows you to extract the text. Yes, so probably this would be the most complicated step. If you have an image, you need to use a computer vision model in order to describe the image. Okay, so you need text, but this could be the most complex part, right? How to extract the text of your data. Well, in this case, very simple things, 2 text files. Well, never mind. Now, the save information method from the memory will help us to embed or generate the embeddings of each text and store it in an AI search index. And not only that, it also checks if, for example, if the index does not exist, it will create it for you. And it will also build the required fields. So it will build the field, the index, and the field requires some fields, some vector profile. You will see once I show you the demo. And after you generate the embeddings and store them in the vector database, you are ready to ask questions about it. In this case, well, we are building a plugin on the fly, right? So here we have the prompt. Well, yeah, we're using TextMummy plugin, by the way. This is already native from Semantic Kernel. The idea is that it will allow us to use this recall function. Recall basically is used for chat history references, right? And it is very simple to use. So please notice that here we have 2 variables, fact1, fact2. We also have history and user input. We will provide these values later. In the next slide, you will see the code. But here you prepare a simple prompt, okay? But you will pass some arguments. So the AI assistant has some chat history, some context to answer them, okay? All right, so we create a function from this prompt. We pass some basic settings, such as the limit of tokens, the temperature for the OpenAI model. And this is where we start connecting everything. We prepare a kernel arguments, which basically is a dictionary of string and keys. Sorry, string and values, keys and values. So we have fact1, fact2, which you remember we mentioned it here, fact1, fact2. And we have cosine similarity and dot product. Then we have some other elements, such as the index that we are going to use to answer the questions. What is going to be the knowledge base that the AI model is going to use? And some other arguments. These are for the search, right? Relevance para means that, for example, when searching using the index, if the score is lower than 70%, it will not be considered as part of the result. Of course, we want answers closer to 1 because that means that a match was found. Don't forget that our search is semantic. So it is not full text search. It will not find the precise terms or words. It will look for searches that are similar in words, right? Okay, and the history, which at the beginning is empty. But now, here we create this chat function, and here we provide the rest of the arguments, such as user input, and also, again, the history. In this case, the history is updated with the answer from the AI assistant, right? Because here we are asking some question. What are 2 applications of dot product? This is the input that we provide in the arguments. The function is invoked, and we get an answer from the AI assistant, and we print it. The answer, the result, well, is passed to the history, is concatenated. So again, as I said, we are creating a very simple chat history. So next we have second question and third question, right? So let's test it, and you will see some results. Okay. So just a second. I will answer your questions after this. Okay, so the code I already mentioned, it is exactly the same, but I will add breakpoint here after the index is created. And just a second, I should have, well, I probably need to enter the Azure portal. So you will see that my index is not created yet. What's the index that I am using? I am using this index, reactor index, okay? Okay, reactor dash index. And I will show you that the index is not there yet, okay? I have my resource here. Yes, so you can see there is no reactor index, okay? Well, let's run this application. Oops, and okay, oh, sorry. Okay, now let's go back to the Azure portal. And you will see that we have a reactor index with 2 documents. And they are already vectorized because this is the index vector index size. So click on it, and you will see that we already have the fields for this search index, ID, embedding, and other information, text, description, additional metadata. We can check the semantic kernel documentation in order to know how we can control this, like what fields we want, but these are generated by default using semantic kernel. And also some vector profile that is used, some algorithm, right? So only with, of course, the setup, but especially these 2 lines made it possible, right? That these 2 documents, as you can see, this is some basic text about cosine similarity or dot product, right? But the vectors were generated using the embedding model. So with very few lines of code, and if you have used Azure AI Search SDK or the REST API, you know that you need to do a lot of things. Prepare the fields, right? For example, you require a lot of code. And in this case, very simple to get the solution. And now it is ready. It is available for us to ask some questions about it. And here you can see, I am asking, what are applications of dot product? Well, we have measuring similarity between vectors, calculated weighted sum of inputs, perform collaborative filtering. I got this information, please notice, dot product from here. This is measure similarity between 2 vectors. Yes, this is mentioned. Neural networks is mentioned somewhere, and collaborative filtering. Yes, so it used this knowledge, right? Also, we also mentioned, right, that it shall use the current memory, right? So, and the search index, yes, this, because we are passing this argument, so it is not using the base knowledge, but the new one. Okay. And yes, we can also do some other questions. What is cosine similarity? And this is the definition that is from here. Measure the degree of similarity between 2 vectors. Yeah, measure similarity between 2 vectors, multidimensional space. So it is using more or less those words. Is computer vision an application of cosine similarity? This is tricky because I am not mentioning computer vision. However, the answer is yes, because in the applications part, we are mentioning image recognition. Yes. And it is actually here. Cosine similarity can be used in computer vision to compare the embeddings of 2 images, which can help with image recognition tasks. Yes. I did not use the exact words, but the answer was obtained. And well, this is possible because of the embedding. So with very few lines of code in less than how many? Less than 100, you have RAG solution. So you again, with semantic kernel, you focus on the code, right? You focus on what's important. Okay, Pablito, back to you.
Excellent, Luis. Oh, your explanation of memory using RAG pattern, step by step, of how to understand it. Well, perfect. Alicia, can you switch to my screen? Perfect. Well, let me share this link in the chat. Perfect. Perfect. Well, you can run this repository locally or on Azure. Here, it shows us the requirements that need to be installed, as well as the necessary resources in Azure OpenAI or OpenAI. Well, then there are the instructions for running it on Windows or Linux, Mac OS, depending on the system operator you are using. Basically, well, you clone the repository, okay? Then configure the Azure resource. Remember from the first episode that we need to have the resource created in Azure with our GPT model and embeddings model deployed, and then obtain the endpoint and the key to connect. Well, here we have the code. Let me show you. Here we have the code and already have it running locally. Okay. Um, we can use Azure AI Search here, like Luis explained. But in this example, I'm only using it locally without saving anything, just using it in memory. Well, here I run, in my case, I use Windows, I use start.ps1 and compile it successfully and run it. Let me show you. This is the solution. Let me, for example, upload a document. For example, in my case, I will use my resume. And well, let me, for example, explain you something. Well, here we have the plugins. Okay. For example, we have different options where we can connect it to my custom plugins, as we saw the other day in the demos. I can also configure it with my tenant for Microsoft Graph, Jira, and even fetch information from GitHub repository. These are already pre-configured in this repository, but you can add whichever plugin you want. Well, I upload my resume or my CV here. I can start asking questions. For example, what is the last position or role Pablo is working in? And Okay, perfect. Well, yes, it's true. Pablo Piovano is currently working as the director of AI services, cloud services at OS Digital Consulting, a role he has held since April 1st, 2024. In this position, he leads the strategy and implementation. Well, explain this role or summary this role. And well, we have the citation, yes. Well, here is the same thing Luis showed us, but instead of using Azure AI Search, it uses the local temporary memory. Okay. For example, we have different options. Yes. Now I'm using the text file, but sorry. We can use Azure AI Search, Qdran, or this is in preview experimental. This vector database in your local host. Okay, but now I am using a text file local in my laptop. Okay, well, let me ask another query, another question. For example, what city does Pablo live in? Let me. Okay, Pablo Piano lives in Sunchales, Santa Fe, Argentina. Let me open the. Well, maybe have an issue here. It's not, but well, let me find if I. 1 second. Here, perfect. Here, perfect. This is my resume, and well, here, obtain the information. For example, when I ask it my last position role, extract the information using or understand the date, or in this case, this present. Okay, and well, we can use rack pattern. Well, we want to share this demo and the repository with you because you can use it as a starting point to integrate semantic kernel into your web application. It's not something you use in production, but let me, here. This is something not for production, but it does allow you to learn all the concept we have been discussing throughout the season of AI. Well, I hope you liked it. Well, if you need help or assistance with how to run this solution, please ping me using the social media, LinkedIn mainly. Well, what do you think, Luis?
Well, it's very interesting and easy how we can use this technology, semantic kernel, library, Nugget packages, to achieve, let's say, there was some mention about LangChain. Yes, exactly. As we mentioned last week, semantic kernel is inspired on building some orchestrator that allows you to connect, to plug in several capabilities. And well, LangChain, it is true that it does the same. But well, semantic kernel is helpful for C# developers and also for Python and Java. Well, so there were some interesting questions in the chat. Sorry that we could not answer all of them, but there are some use cases interesting, such as Microsoft Graph, for example, synchronizing the documents. Like we have some base document, it was updated, so we need to, of course, update also the embedding. So it is also possible with semantic kernel, very, very simple. So, well, I think we can like take it from here, and maybe we might have some other session where we discuss some interesting use cases about semantic kernel. Thank you everyone for joining. There is a question from Oscar. Hey, hi Oscar. How mature semantic kernel is compared to LangChain? Well, it would be interesting to find some comparison. Let's say that, well, you can use semantic kernel in production. I mean, it is ready to production. Some things are experimental, and actually you get an exception. You need to disable it if you want to use it. But core capabilities are already there. Let's say because of these experimental things that it is a work in progress, so it might not be as strong or as mature as LangChain, but it gets inspiration, let's say, from it and its own capabilities. And also with the support of the community, I think it will be an option, at least as I said, for .NET developers. If you are a Python developer, I would recommend to use LangChain, I mean, because it already has a lot of capabilities. It started before, and it is true that Python is a huge community, especially in the data science and machine learning field. For developers, well, you might discuss that there might be more C#.NET developers focused on applications, on solutions, than Python developers that focuses on solutions. Okay, so well, yeah, it all depends on the criteria. But I mean, you can use it, but if you know Python, go for LangChain. I mean, it has more capabilities. Sure, stay here. Okay, thank you for your question, Oscar.
Well, you already know you can reach out to us on our social media for any questions about these topics. You can also revisit or review any of the previous episodes to refresh your knowledge or get a quick review of any topics. We went through a bit faster today as we approach the final part. Well, thank you very much to the entire audience. Thank you, Alexia, for the behind the scenes support. And thank you, Luis, for sharing the stage in Reactor and in our community.
It was
Thanks.
a pleasure, Pablito, to join everyone in this event. So we are happy, we are delighted. We are also sad that it ended, but well, we will see. I met you for sure in future events. So have a nice day, everyone, and see you next time.
Thank you both so much for this session in this series. We will definitely see you very soon. And thank you everyone in the audience who've been attending the series. And yeah, until next time.
Thank
Bye,
you.
everyone.
Bye-bye.
Bye-bye.